Hi, hello everyone. Good morning and good evening to whichever part of the world you are in. A very warm welcome to each one of you for today's live session. And for those unattended, just a bit of context about DeFi. We are a data science community that is envisioned to shape the future of AI and democratize data education. And in our endeavor to constantly give back to the community, we regularly conduct boot camps, live sessions from industry experts, datathons, and other events. And today's session on serverless deep learning is one such initiative, and our heartfelt gratitude and thanks to Alexey for kindly agreeing to do this. And I'm confident most of you know about him, and most of you must have been following him on LinkedIn or on his DataTalks.Club Slack or YouTube channel. And if not, please do follow him. And also for those unattended, Alexey is the founder of DataTalks.Club, and also he's the principal data scientist at OLX Group. And he's a software engineer with a focus on machine learning, and he's passionate about bringing data science ideas from early prototypes to production, which includes problem identification, data collection, model creation, deployment, and maintenance. And other than that, his contributions to the data science community are invaluable, and he continues to support many data enthusiasts through his live sessions, tutorials, and regular updates on LinkedIn and on his Slack and YouTube channel, DataTalks.Club. With that, once again, I would like to thank Alexey for joining in with us today. With that, I'll let him take over the session. Thanks, Alexey. Yeah.
Thanks a lot for inviting me. So actually, I wanted to introduce myself, but I think I don't have anything to add. So then let me just, I think I need some permissions for screen sharing.
Yeah, you can do now. Yeah, sorry.
Yeah, I know it's annoying. So I was going to use this as a way to introduce myself, but thanks for introduction. I don't think I need to add anything to this. So yeah, I'm also on Twitter. I work as a now principal data scientist at OLX. And for those who don't know what OLX is, this is an online classifieds platform. Those who are tuning in from India probably know OLX, which is a place where you go to sell something or buy something. We're not only present in India, we're also present in many other countries. For example, OLX Poland also is quite a big marketplace in Poland, and we are present in many countries. So if you're interested to learn more about OLX, you can go to olx.com, and when you will see about all our marketplaces, all our markets, and you also can find open positions that we have. Yeah, I also would like to encourage you to join a data community. This is my hobby. I run a data community, and if you want to talk about different data-related topics, then DataTalks.Club is a great community to join. Just go to our website, DataTalks.Club, and then enter your email address, and you will get an invite to a Slack. And now I will start. So the topic for today is, we'll talk today about serverless deep learning. So let's start first with the serverless part. So we will use AWS, but for all we do today, if you use Google Cloud or Azure or some other cloud resource, there is an alternative alternative to that. So you can also use serverless functions from there. So today we will use AWS and we will use AWS Lambda, but these should be transferable to any other cloud provider. And so let me just first show you what we want to do. So let's say we have a deep learning model. So this is a model for images that takes in image as an output, and then it produces some output, like it produces the probability that this image, and an image we have close, it belongs to one of the 10 different close categories. So on this picture, we have a picture of pants, then we put it to a model, and then if the output is 10 different classes, and for pants, we have the highest score. What we want to do today is we assume that this model is trained, so we will not cover the training part today. What we want today is to take this model as is. This is a pre-trained model. And this model was trained using Keras and TensorFlow. We want to take this model and we want to put this, we want to deploy this model in such a way that we can just query this model and get back the predictions. And for that, we will use AWS Lambda and we will use TensorFlow-Lite. And let me say a few words about AWS Lambda. So if you go to this AWS console, and if you go to AWS console, and if you put Lambda there, so it says Lambda is a service that lets you run code without thinking about servers. And this is why we want to use Lambda, because with Lambda, it just gives us an opportunity, a platform for deploying our functions, our models. And we don't need to worry about things like provisioning a web server, provisioning like AWS instances, and then thinking how to use them most. So we just get a function, we just execute the function, we don't worry about the servers, and we pay only for the execution time of this function. And this is how AWS Lambda looks like. Sorry, I think I need to go to Lambda. Yes. So in AWS Lambda, so if we can create a function, I'll quickly just create a function. Let's say we can call it image classification, and we will use Python. We will not touch anything else. And in this function, so it will just create now just a basic function, the default one. Takes some time. Cool. Yeah. Yeah. So what we have here is yeah. So there's already some pre-generated code. So what we see here is we see two things. Let me enlarge it a bit. So we see well, some imports, and then we see the most important thing here is this function. So this function is called Lambda Handler. And this gets some event. So event is what we send it. So we can send an image here in this event. Then we do something here. So we'll load our model, we apply our model, we do some pre-processing. And then we get some output and we return this output here. So here we would have these predictions, right? And we can easily deploy this in AWS. And this way we will be able to serve our models. And yeah, so just let me quickly show you how it will look like at the end. So yeah, so this is a chapter from my book, and this is what we will use today as material, but you don't need to have a book. And here actually, let me quickly tell you that there are some resources here in the description. And if you go to this code link, so this the very first link, if you go to this code link, you will get all the code you need for this session. So you don't need to worry about trying to, like if I speak too fast, yeah, you don't need to worry about this. Everything that I say today is in this repository, and then at your convenience, you can just go there and go through all the instructions and reproduce what we say today. And the most interesting link here is this one. So there is just end-to-end tutorial that starts from the very beginning till the very end with all the code, all the explanation that you can follow along later. So now let me go back and explain what we want to do. So we have this Lambda handler. So this is what our Lambda created here, right? So it gets some event, and in this event, we have a URL, the URL of an image. And it's not, so let me just, oops. No, this is wrong. Anyways, so here in this URL, we have an image of pants that I think you just saw it recently. So there is an image of pants. So we get it to, it goes to this event parameter. Then we extract this URL, we do some pre-processing, then we apply our model, we invoke this predict function that you will see later. And then we do some post-processing of the model output, and then the result is the prediction. So this is the goal for today. This is what we want to do. Yeah, let's start. So where's my, yeah. So we will start with that. So as I said, this is already a pre-trained model. So this model was trained previously, and as I said, this is based on the book. So there is one chapter of the book where we train a model, and as the result, at the end, we have this model saved as H5 file. So we have model weights, and now our task is to take this model and to deploy it. But first, we want to see how to actually use this model. So this is a Keras model. So to load this model, we usually do Keras models load model, and we get this model that we can use with Keras. And then, so what we need to do first is we need to get an image. And for that in Keras, we use a special function for that called load image that just loads an image. And then after we loaded the image, we need to pre-process it to, so the network, the neural network that we have here expects the image to be prepared in a certain way. And we don't always need to know what happens exactly inside. We just need to know that this function has to be applied every time we invoke a model. Before that, we need to apply this function to our image. And it just standardizes, does something with the image. So we need these two functions. And this is our labels that we have. So we have 10 labels of different clause. And what we do, we use this function from Keras to load the image, right? So we load the image, and the image has to be of certain size. So we cannot just take any arbitrary image. The neural network expects the image to be in a size 299 by 299. So we take the image in this size. So we load it. And then, as I said, we need to pre-process this. So we need to first convert this image to a Numpy array, right? So then it becomes, maybe I can just quickly show you what's going on. So while it's loading, I'll keep talking. So we take this image, we put it into a Numpy. Oops. Yeah, that's better. So now we have this image variable, right, which contains the image. And what we need to do is we need to convert it into a Numpy array and apply this pre-processing function. And then at the end, this is how our the input to our model looks like. So it's just a bunch of numbers. And the shape of this array is, because this is how our image is. So we have just one image. And the image, the dimensions of the image are 299 by 299, and there are 3 channels. So this is the input to our model. Then we apply our model, and we get back some predictions. So here, these are not probabilities. It's not processed predictions. It just outputs some score. And here, the idea is the higher the score, the more likely the image belongs to a certain class. And we can make it more human readable by joining it with labels. And then at the end, we see that this is pants. So this is the most likely class. So this is how we use with Keras this model, but there are problems with this approach. So the main problem is that we need to use this preprocess input function, right? This is a problem because if we want to use this function lives here in this exception, which is a part of TensorFlow. So it means that for this tiny function, we need to import an entire TensorFlow library, which is pretty big, right? And then since this TensorFlow is too big, this is another problem. This is even bigger problem. We cannot just take Keras model and put it into Keras and put it into a Lambda function. They are too large. They require too much resources. They will load too long. And half a year ago, it wasn't even possible. So Amazon, AWS, they adjusted the resource limits. but half a year ago, it wasn't even possible to put TensorFlow in the Lambda function because of some limits, right? So using TensorFlow is a problem, and we want to avoid this. And the solution for this, instead of using TensorFlow, we can use TensorFlow. We can use TensorFlow-Lite. And TensorFlow-Lite is a special library. This is, if you see, it's for machine learning for mobile and edge devices. Lambda function is not really a mobile or edge device, but this TensorFlow-Lite is optimized for inference. It's very slow, or it's very small because we can put it to a mobile device. So on mobile, we have certain limitations, right? So we want our runtime as small as possible. And this is really great. So this is what we need. So we want to have something as small as possible that just is doing our job and not doing anything else. And we only need serving here. That's why we will use TensorFlow-Lite. TensorFlow-Lite expects a model in a certain format. So where it is? Yeah, so it expects models in a certain format. So we cannot just take a Keras model and put it into TensorFlow-Lite. We need to first preprocess it. And this is very easy to do. So in TensorFlow, there is a thing called TensorFlow-Lite converter that takes in a Keras model and produces a TensorFlow-Lite model. So we just need to take these, I don't know, 4 lines of code, and that's it. So we just need to put our Keras model, and then as the result, we will have a TensorFlow-Lite model. And with this TensorFlow-Lite model, we can use TensorFlow-Lite instead of big, huge TensorFlow. And just for comparison, TensorFlow, if you take just the Python package, and if you compress it, the size will be 1.7 gigabytes, right? It's just TensorFlow, all the things is as a Python package. It's huge. And if you take TensorFlow-Lite, it will be around 50 megabytes. So it's a lot smaller. And that's why we want to use it, because we want our function to load faster, and we don't want to have this overhead of loading 1.7 gigabytes of TensorFlow. Right? And so we convert it. And then to use TensorFlow-Lite, it's a bit different from using Keras like we used previously. So if you remember, here in Keras, all we need to do was that, just model.predict, and we're done. We have the predictions. Well, of course, we also need to do some preprocessing, but at the end, it was just that model.predict, and here are the predictions. With TensorFlow-Lite, unfortunately, it's a bit more complex, but the good thing is you do this just once, and then you copy-paste this code from your project to another project. And this is how it looks like. It's a bit complicated. I don't know if I need to go into details, but yeah, so the main idea is you first create an interpreter, which you use to load your model. And then you do some, you need to get the input to this interpreter, and you need to get the output from this interpreter. And then you take your input that we had previously, this X, big capital X matrix, right? So we take that, and we need to put this to this input of the interpreter, right? And then we invoke the interpreter. What happens internally is we take this capital X, we take our Numpy array, we send it to the model, it goes through the model, and then there is some output. And then we take the output from this output index, and we say, hey, interpreter, whatever is there on the output, just give it back to us. And that's basically it. So instead of just model.predict, it's more complex. Yeah, there's like 10 lines of code, but it's easy to just put it in a separate function and not worry about this at all. And the predictions, as you see, look exactly in the same way. So this is the same capital X that we used previously. So it comes from here. So it's the same function. And yeah, we just put it here and get back the predictions. And as you see, the predictions are again pens, right? So it works, but I already mentioned that TensorFlow is too big, and we have a problem with this function, preprocess input. This is a small function. All it does, it takes not prepared NumPy array and does some processing to it. So it just does some NumPy manipulations and then outputs some prepared array, right? And it's not doing anything else. For this function, because it lives in TensorFlow, we need to import it from TensorFlow. It means that in order to use it, we need to bring with us the entire TensorFlow package, which, as I said, is 1.7 gigabytes in size, which is huge. And just for one library, it's not worth, just for one function, just for this preprocess input function, it's not really worth bringing this entire big thing. So what we can do now to get rid of this dependency is to use a library that is called Keras image helper. And I can quickly show you this. So Keras image helper is just a library that encapsulates all this logic of preprocessing in a separate function. So you don't need to import the entire TensorFlow for that. Yes, so Keras image helper. And yeah, so it has this preprocess input function that we can reuse and not depend on the entire TensorFlow library. And I can quickly show you what it's doing. So this is what it's doing. So there is this simple function that we need to invoke, right? And for this function, for these 4 lines of code, we don't really want to import the entire TensorFlow, right? So this function helps and it makes this process a bit nicer. Because for different Keras models, the preprocessing could be different. So there is some logic on top of that. But at the end, it boils down to just using this simple function for our model. Some Keras models use a different preprocessing functions. And this library also knows for which Keras model, which function it should use. But at the end, yeah, it's just these 2 functions. So instead of importing the entire TensorFlow with us, just for one function, we can use this Keras image helper. And here we say, okay, we need a preprocessor, a function that would take our image and output a NumPy array in the format we expect. And this is how it works. So let me just import it. And yeah, so this is the image of the pens that I wanted to show you. Here it is, right? And then this is how we invoke it. We say preprocessor, here's our URL. Please fetch the image from this URL, apply the preprocessing function, and return us the array. And as you see, the array, well, maybe you don't remember the numbers, but this is the same array as we had previously. And we can just again invoke it and use it for preprocessing. And yeah, so this is the main idea. This is how we use TensorFlow-Lite for converting, for using Keras models. And this is the code that we need to put in our Lambda function now. So we need this bit. So this, these few lines, we need this line, and we need this line, right? And we now need to take this. And if you remember, we had this Lambda function. We now need to take all this logic and put this in Lambda function. It's not enough to simply copy and paste this because in Lambda, in AWS, we don't yet have TensorFlow-Lite, we don't have Numpy, we don't have all the libraries that we need. So now what we need to do is to take this code, put it in a Python file, take all the dependencies we have, and put them also in something that will let us publish this to AWS Lambda. And let me show you how it looks like. So for packaging, so let's first go with the Lambda function. So this is the code you already saw. So we take TensorFlow-Lite, we take this Keras image helper, we create this preprocessor, we initialize this interpreter. You have seen this already in the Jupyter notebook. And yeah, I realized that maybe I'm moving too fast, but remember that all this code is available in the description. So you can just go to the description of this video and find all this code and reproduce this. So we have this interpreter, we initialized it. We know what is the input of the interpreter. We know what is the output of this interpreter. And what we can do now is put this logic in a predict function. The function will take this capital X as an array, and it will invoke the interpreter and will give us back the results. So and this is what we use here, right? So we have this Lambda handler. This is what Lambda, the environment will invoke when it gets an event. So the URL will be here in the event. And here is the predict function that we just looked at, right? So this is what we invoke. To get this X, we need to use the preprocessor. So preprocessor just gets the URL and returns this Numpy array. And then as a last step, we need to, if you remember, let me show you once more. So we have these predictions, and it's just an Numpy array with numbers, right? So we need to convert this number into something human readable to this format. And this is exactly what decoding predictions function is doing. So it takes the predictions, it takes the labels, and it puts them together in such a way that the result is human readable. So that's all. It's just 40, like almost 50 lines of code. So not a lot, right? So now the next step is we need to deploy this function, right? So we need to make sure that the function has all the dependencies. As I said, we need a dependency to TensorFlow-Lite, we need a dependency to Numpy array, and we also need this Keras image helper dependency, right? So we can go to do this, we can package all the dependencies in Docker. So since November, I think last year, AWS Lambda actually allows to deploy Docker images, and this is what we will do now. So we will package all the dependencies in Docker. So we will take, this is quite an old image, but it doesn't matter for us if it's to Python 3.7 or 3.8. Maybe 3.8 is actually better, but I'll stick to 3.7. And we need to, for those who don't know Docker, this is just a way to execute all these commands and at the end have sort of an isolated environment with all the dependencies we need. So inside we will install this Keras image helper module, and it will make sure that we have this library when we execute the Lambda function, right? And then we also install TensorFlow-Lite. It's I need to explain what's going on here, because instead of just doing pip install TensorFlow-Lite, it installs this long thing, right? So the reason it needs to do this is because by default, TensorFlow-Lite is compiled for Ubuntu, for Debian-based Linuxes. So because in Docker we run Linux, and it's compiled for Debian-based Linux, but for Lambda, for these prepared images that AWS has, it's a different type of Linux distribution. So they used, I think it's CentOS based, but it doesn't matter. So it's a bit different distribution from Debian. So what we need to do is we need to recompile our TensorFlow-Lite package into something more Debian friendly, or no more CentOS friendly, because if you just do pip install TensorFlow-Lite, it will not work. And here, this is already precompiled dependency that works in CentOS, that works in Amazon Linux. And if you're interested how it works, I can show you if you go to my GitHub, and if you go to repositories, I think it's Lambda. Yeah, so we have this AWS Lambda model deployment workshop. If you go there, oops, I think it's wrong. Yeah, probably this one. Okay, sorry, I don't think I remember where it is. I think I can just look here. Okay, it's serverless deep learning. So if you go to serverless deep learning, yes, this is serverless deep learning. And here is the instruction of how you can compile it for yourself. So it was a while ago. I think it was, yeah, 1 year ago. That's why the version of Python is a bit old. But yeah, you can just find this repo. And if you're interested how to do this, if you're not interested, you can just take this and use it and don't worry about this. But if you're interested how to use this, you can go to this serverless deep learning repository and take a look how it's done. Yeah, so we have this. So we install everything. Then the next step, what we do in a Docker file is we take the model, the TensorFlow-Lite model, and put it to the Docker image as well. And as the last step, we copy our Lambda function. So all this code that we have here. And when we do this, after executing all these lines, what happens is our Docker image contains all the dependencies we need to actually run this Lambda function. What is more, now, before even deploying this to AWS, before even deploying this to Lambda, we can test it locally. And I will show you how. So first, we need to build this image, build this Docker image. So I hope I'm in the right. So let me make it a bit larger. Yeah. So it finished, this command finished very fast because I already did this previously. So all the results are cached. So now we have this Docker image with all the dependencies we want, and we can run it. So to run it, we just copy this command. And again, everything is in the README file. You will be able to rerun it on your own. So, okay, we have this, right? So I think it started. So what we can do now? So right now, this thing is deployed. Our Lambda function is deployed locally. So we just executed this Docker container on our machine. So what we do now, what we can do now is we can execute this, this and see the output. So first I will show you how to do this with console, just to check with terminal, just to check that it works. Yeah, I was testing it here previously. So yeah, so this is URL. So the URL is, it lives on localhost. This is the request we sent. So the request is this image of pants. And this is how we use curl to send this request, right? This is the response. So for those who are not familiar with curl, what I will do now is I will translate this code to Python. I think it's, oops, sorry. It will be easier to understand now what's going on. So let me just copy it here, and we will use requests for that. So in requests, requests for those who don't know, it's a library in Python for making HTTP requests. So we need to send a GET request for this URL. So let me just copy this URL first. So this is the URL of our Lambda function. So we need to, I think we actually need to send a post, not a GET, right? And this is the data we sent. So this is our data, or yeah, the data is we have the image of pants, and they are put in a dictionary called, like in a dictionary, it's associated with the key URL. So we have this request. Now we need to send a post request with this data to this URL. And this is where our Lambda function is deployed. I think, yeah, so we just do something like this, JSON equals data, and then the result should also be JSON. Yeah, so this is how we do it with Python. So we send a request to this URL. We use this data as a body of the request, and we get the results as a JSON object. And we see that the pants is the most likely class. So now what we need to do is we need to deploy this to Lambda and test it there. So yeah, for that, I will not do it right now. What I have is, because I have done this already, and I will just show you how to use it. In AWS, there is a thing called ECR, which stands for Elastic Container Registry, which is a place that keeps all the Docker images. So this is a place where you can upload your Docker image, the image we just created, and it will live there. So let's go there and see. Yeah, so we have these Lambda images. So this is the this image that I showed you. So it has this Docker file that I already published to ECR. And what we need to have now is this URI of this image. So let's just copy it. So we copied it. And now we need to put this into our Lambda function. So I will delete the Lambda function that I created. And I will create a new one. So we need to, last time I used this option, author from scratch. But now, since we have our code in a container and our dependencies in a container, we need to use this option, container image. And this is, so remember, I copied the URI from here. So we take this URI and put it here. So container image. And then again, use clause, for example. Let's call it clause classification. Yeah, and we don't need to change anything else. So we just create a function. Oops. Yeah, I think instead of copying the whole thing, we need to copy the image URI, not the URI of the. So previously I copied the URI of the repository, and we also need this this tag here. Okay, let's see if it works. And just to, maybe I was too quick. What I did is I went to repositories, ECRs. Then I clicked on the repository. Then I selected one of the tags here, which I deployed, I think, more or less recently in May. And then I clicked here, copy the URI. And then I put it here in Lambda. Yeah, so this time, because we use image, well, the function is not visible. The code is not visible. But we know what we deployed. So what we need to do now is adjust it a little bit. So the default settings for which we run our Lambda function will not work for deep learning. So because for a deep learning model, we need to give it a bit more resources. So we go, I think, to this configuration tab. And in configuration tab, we choose general configuration. And as you see that this Lambda function gets 128 megabytes of RAM, which is not enough. And the timeout is only 3 seconds. This is also not enough. I will explain. You will see later why. So what we need to do is give it more RAM. So I would go with 1 gigabyte, and we'll give it more time to execute. Let's put it 30 seconds. The reason I put 30 seconds is, on average, it takes around 2 seconds to execute this particular model. But the first time when we run it, it takes longer because it needs to get the image from ECR, this image that we have here. It needs to load all these dependencies. It needs to also do some sort of warm up. So that's why it takes a bit longer for the first invocation. Okay, so we give it more RAM and we give it more time. Then we save it. So now we can actually test it. So for testing, we will take the same request we used previously. So it will be the image of pants. So let's call it pants. And yeah, so this is it. It's just a URL. So where do I save it? Save changes and test. So now it will, as I said, it will take some time. So because it needs to load the image, It needs to plot all the dependencies. I don't know. It needs to do some stuff. So that's why the first invocation takes some time. So let's wait a bit. Okay, so it's successful. We can see the predictions that it says, okay, this is pants. This is exactly what we saw here, because this is the same image. And we see that it's pants. And we see that it took almost 10 seconds to execute this, right? But if we do it second time should be a lot faster. So for the second time, we see it's already finished. So it took 2 seconds to run it. And then the third invocation, consequent invocations, will take a lot less time than that. Well, almost ready. Our Lambda function is ready, but the problem with this is we cannot yet access this function. We cannot use this code here, right? So what we want to do is we want to have a web service for accessing this function, right? But it's just Lambda function inside AWS. We cannot use it yet. What we need to do now is we need to expose this Lambda function as a web service. And for that, in AWS, there is a thing called API Gateway. So API Gateway actually gives us a way to expose many different AWS resources, including AWS Lambda as a HTTP, as a web service. So let's create an API. So there are many different types. We will go with REST API. And yes, a REST, new API name, let's call it close classification. Okay, so now we need to define resources. So resources is just a fancy name of what type of methods you have, what type of things you have in your API. So we need to create resource. And resource would be, let's say, our image, or we can just call it predict. Because usually when we deploy machine learning models, this is how we called our API. So from the REST point of view, maybe this is not the ideal name for those who know REST, but we will just call it predict. So let's create resource. Okay, so we have a resource, and now we need to create a method on this resource. We want to send a post request to this resource. So post, okay. And now we need to say that for this post request that we send to this predict resource, we want to invoke a Lambda function. And okay, so there is autocomplete. Yes, and the important thing is not to use this Lambda proxy integration. So it should be turned off. Because I don't remember what exactly proxy is doing, but then it adds something on top of the request. And yeah, so you would leave this alone, you don't touch it. So save it. Okay. I hope it works. Okay, so what now we can do is we can test it. Yes, please. I want to test it. Again, request body. We will use the same request as previously. And let's test it. Yeah, so it was quite fast, 2 seconds again. And yeah, the result is pants. Cool. So what we need to do now with this API gateway is we need to deploy it, to make it available. We will just call this deployment test. And when we do this, it will create a public web service that we can use for testing, for accessing it from the laptop. So yeah, let's just call it test. Okay, and we have this URL. So we need this URL. We again go to the notebook. that I have, and we replace this local URL with this URL. And remember, we created a resource called predict, which we will use here. So this is the where it's deployed, the deployment URL, and this is our method. And again, we send the post request like here. So let's see how it works. And if you see that I'm actually doing it from my computer, right? It's localhost, and it's deployed in AWS Lambda. So now we can use this to access our model in AWS Lambda, and this is how we can deploy a Keras model to AWS Lambda to Amazon using serverless. Maybe just to summarize, so what we did is we took a pre-trained model which could classify images of clothes into 10 different categories. This model was trained with Keras. Then what we did is we took this model and converted it to TensorFlow-Lite because Keras is a part of TensorFlow, and TensorFlow is simply too big to put it into a Lambda function. In addition to that, we use Keras image helper, which is a library for pre-processing images. So we took these two things. We took TensorFlow-Lite, we took Keras image helper, we put them into a Lambda function. Then we package all the deployments in a Docker container. We publish this Docker container to ECR. Then from ECR, we created a Lambda function. And then we exposed this Lambda function with API gateway. And this way, we could deploy our Lambda, our TensorFlow model, our Keras model. I think that's it. I again want to remind you that everything that I talked today, where is the video? So everything I talked today is available. So you can access it here. So the code is here. You just click on this and you will find all the resources. You can also, this is based on the book I wrote. So, okay, it doesn't work. Yeah, so you can also have access here to all other chapters from the book. So for example, in this chapter 7, this is where we train the model we just deployed. So yeah, I don't know why it's here. Probably should remove it. But the interesting part is here, this train. And this notebook goes into details how this was created. So check it out. And then if you want to find out more about the book, the link is there. And don't forget to check out our amazing Slack community. So just put your email here, click join, and you will get an invite in your email within 3 minutes. And then you finish your registration there. And you can have fun in Slack and interact with a lot of great data folks. I think that's all from my side, and I'm happy to answer questions.
Yeah, thanks. Thanks a lot, Alexey, for the wonderful session. I think it was like, it was very seamless. I was hearing out. And someone is asking, can you please elaborate more how you upload Docker image to ECR?
Yeah, maybe let me just quickly show you that. So here in the instructions, we have this README file. And okay. Yeah, so this is this. So first you need to create a repository. You use AWS CLI tool for that. And yeah, then you basically just put your account ID here. Then you put the name of the, yeah, it's here. So put the name here, and then you authenticate with Docker, and then you just do push. So you'll need to do these 5 lines of code. So this one you can do from the AWS console. You don't need to do this programmatically, but this you have to execute from your computer. And this is how you publish. Yeah, so it's also available in the README. I just didn't want to publish because it usually takes a while because the image is, I don't know, it's like 500 megabytes maybe because there is model, or 200 megabytes, I don't remember, but it takes some while to upload. That's why I didn't do this during the session.
Got it. Thanks. Thanks for
I
that.
hope it answers the questions. But if something for some reasons doesn't work, you can find me on DataTalks.Club Slack. Just go to the engineering channel and ask a question there, and I'll be happy to help.
Great. Yeah, great. Thanks. And like, I have a question myself. I'm like, how did you transition, or like, how did your journey to data science begin, or like, what motivated you to take it up generally? Yeah.
So for me, it was a course from Andrew Ng on Coursera. So I was working as a Java developer at the bank, and yeah, I just saw the course. My colleague told me, saying, "Hey, there is a cool course." My colleague was also a Java developer, and he said, "Yeah, let's learn it together. Let's study it together." And we watched that course. I don't think he finished actually, but I did, and I really liked it. And this is how it started for me. So then I started taking more courses, and eventually I got into a master's program, which was probably a mistake. I shouldn't have done master's. I could have saved 2 years. But yeah, maybe it's a different story. But yeah, for me, it started with Andrew N course on Coursera.
Okay, great. Now this brings me to this question, like, what suggestions would you give to someone who is getting started with their data science journey, or transitioning to data science field from a software engineering or whatever it is, because you have done a master's, right? So you have some experience in research and academia plus industry. So yeah, please.
Yeah, I think the most useful thing for me when I was doing master's was the master thesis. And the master thesis was a project that I needed to do end to end. So it was just some vague task from my advisor, and I needed to work on formalizing this task to make a thesis proposal, right? And then what I needed to do next was to collect the data set, do all this cleaning, write a lot of code, and yeah, just figure out how to solve the problem I was solving. And that resulted, apart from 100 pages document that took forever for me to write, apart from that, it resulted also in a GitHub repo, which I could talk about when I was interviewing. And I don't think I ever had a look at my thesis afterwards, the document itself. But the repo with the code was very useful. And I think this is what I would advise everyone to do, is to do projects. Like, you don't have to do masters for that. You don't have to spend 2 years. You also don't have to write this 100 pages document. But it's a good idea to do a project independently, end to end, right? Yeah, of course, it's good if somebody shows you how to do this. Like in my case, it was advisor, but he was also more like a consultant. He wouldn't really tell me what to do. I would ask him, and he would tell me, okay, yeah, maybe try this or that. So it was really great. Yeah, I think if anything, if you want to do something, then doing a project is the best way. And then, of course, like, I'll do a shameless plug. You can read my book, of course, if you're a software engineer and want to transition. But yeah, there are also many resources that you can find online. But the best thing you can do is do projects. Just find a project that is interesting to you. It can be something as silly as, I don't know, scraping a website with, I don't know, houses for rent, and then using this data to predict these prices, right? Building the whole pipeline for that. It's already a good project, right? Especially if you do this from the data collection to model training to model, like exposing a model as an API. This is a lot more than a typical candidate would do. So a typical candidate would find a data set on Kaggle, train a model there, and have a Jupyter notebook in their GitHub profile. And if they do this, like, it's kind of rare anyways, but you can really set yourself apart if you do this thing end to end. If you also include the data collection phase, if you also include data pre-processing phase, and if you include the model deployment phase at the end. It can be something as what we saw today, right? And if you saw, this is not that complex. Like, I haven't shown you a single formula today, right? There was not a single formula today. And you don't need to worry about this stuff. So it's a pure engineering problem. And if you're a software engineer, for you, just doing this and then getting an endpoint which you can access is already a big win, right? So you can, like for a software engineer, what we saw today, it should be easy. For somebody who is maybe from academia, who is more used to formulas, the stuff today was probably complex. But for engineers, that should be the stuff that they're used to.
Yeah, aligned totally. Thanks a lot for the insightful inputs. And I think that's pretty much for the day. And for those, I mean, like if you have any more questions, feel free to ask your questions on DataTalks.Club Slack channel, or you can also post it on our Slack channel or the discussion forums.
I am also on your Slack channel, so just tag me in any channel that you find appropriate. Just tag me, and I will be happy to answer. So great. I have it on my mobile phone. I hopefully should get a notification.
Great. Yeah. Thanks a lot for that. And before we wind up, last one question. So how do you find time to, like, you know, I'm sure, like, you know, you're pretty busy with the ongoing, like, you know, job and everything. So how do you make time for the community and run it with so much passion? So I think it'll be,
I just don't sleep.
Okay.
No, that's a joke. Good. No, it's a long story. Maybe we need a separate podcast for that, separate talk. But prioritization and automation. Maybe that is what. So I write simple scripts for doing all this mundane work. I also use tools like Zapier for integration.
Right.
And probably these are two maybe secrets.
Yeah, I mean, actually, like, you know, the first answer that you gave is not really, I mean, it's actually a good answer. You sleep less and, like, you know, you end up finding more time, and you end up doing a lot of good
I
work.
do not advise anyone doing that. So I don't know, maybe you have to put your videos 18 plus after that.
Yeah. And thanks a lot for the session, Alexey. It was nice interacting and, like, you know.
Yeah, thanks for having me.
Thanks
a lot.
And bye. Take care. Yeah.